Okay, so this is video number 2 in Redox chemistry. In video number 1, we assign oxidation states. For example, in H2O, the oxidation state of oxygen is -2, the oxidation of hydrogen is +1. If we have this, MnO4-, we know the rule, oxygen is -2. That means the manganese must be -2, -1, -6, -8, +7. So this sort of skill, we assign oxidation states. In today's video, we're going to be looking at redox half equations. All right, so firstly, I'm going to tell you what a redox half equation is. And I'm going to do that sort of by example here. If we have a chemical reaction, I'm going to write down a typical redox equation here. So if I would say, I've used this as an example before, if we've got some magnesium and it reacts with copper 2+, you're going to make Mg2+ plus Cu. That's an overall ionic equation. What a half equation does is it tells the story of each of these elements in terms of its loss or gain of electrons. So if I was to look at this half equation, so the overall equation, I know the magnesium goes from 0 to +2, and I know the copper goes from +2 to 0. So the half equation for this would be copper 2+ turning into copper, Mg turning into Mg2+. And the purpose of this video is to learn how to balance these. This one's pretty straightforward, by the way. It's going to be this and this. Danger is they're not always this straightforward. So I'm going to give you an example of one that's not straightforward and an example of something you'll be able to do by the end of this explanation. So if I showed you this redox reaction, bear with me while I just balance this. We've got MnO4-, that's manganate. I'm going to put some acid in there, H+, I'm going to put 5Fe2+. This is an equation from A2. Mn2+ plus 4H2O. Now this is a classic A-level redox reaction. I can tell it's a redox reaction because I'm going to do my oxidation states. Oxygen is -2, manganese is +7. H+ is +1, iron 2+ is +2, iron 3+ is +3, manganese 2+ is +2, hydrogen is +1, oxygen is -2. All right, I know I'm quicker than you, but just deal with it. All right, the manganese in here has gone from +7 to +2. And the iron has gone from +2 to +3. Hydrogen has stayed as +1, +1. Oxygen is -2, -2. So what we have here is an overall equation that I know is definitely redox because these numbers have changed. All right. So by the end of this lesson, what we'll be able to do, where this curly arrow is, this represents the story of manganese, and I know that MnO4- has become Mn2+. And I know that Fe2+ here has become Fe3+. By the end of this video, you should be able to balance both of these half equations. Fe2 plus Fe3+, by the way, is going to be very straightforward. This one, less so. I'm going to balance it now. You won't know what I'm doing. 4H2O, 8H plus, 5E-. Would you like to be able to balance half equations? Keep watching. That's a thumbs up. I want thumbs too big. Right, okay. So that's what we're going to be doing today. Balancing half equations. All right. So strap in. This is what we're going to be doing. You're going to learn some rules about balancing half equations and how to do them and how I like to teach them. All right, so what we're going to do then, how to balance half equations. We're not going to look at overall equations, we're just going to give you some balancing half equations. So I'm going to give you some rules. Number 1, balance any elements which change oxidation states. This will all make sense in a minute. Number 2, balance oxygens with H2O. Number 3, balance hydrogens with H plus. And number 4, balance charges with E minus. All right, so that's going to be our plan. This will make sense when I show you. So balancing half equations. These are going to be the rules that I'm going to refer to, and you should have this sheet called writing half equations. It's got its own rules there, and we are not using their rules. We are using Norton rules, which are just more common as well. All right. So what we've got here then are a selection of challenges that we're going to work through. I'm going to do a few as an example to show you, and then you can do the rest. That's it. This is lesson 2 on here. All right. Balancing half equations. So in each of these, what you've been given is you've been given a story of an element. It's just one story. It doesn't give you any context to it. It just says that you've got sodium forming sodium plus. So it's got no other element involved in it. It's just asking you in this task to balance this half equation. So I'm going to write that. I'm going to write the arrow. I'm going to write Na to Na plus. All right. Step 1. Balance the elements with a chart which change oxidation state. 0 to +1. They're balanced. I've got one there and I've got one there. So I don't need to do anything with this. Balance any oxygens with water. There's no oxygens involved. So I don't need to do rule 2. Balance hydrogens with H+. There's no hydrogens involved. So I don't need to do rule 3. Which means I now go to rule 4. Balance charges with E minuses. Okay. So I didn't need rule 1, 2, or 3. I just needed rule 4. I've got to put electrons on one side of this equation or the other. All right. So, an electron is an E minus. Overall, this side has got a charge of 0. There's nothing charged on this side. And this charge has got a charge of +1. So I've got to add an electron onto one of these sides to make the sides balance. I'm going to put it on this side. Because a plus and a minus cancel each other out. And that means this equation is now balanced. All right. I want to show you what would happen if I put it on the wrong side, because people always put it on the wrong side. Na to Na plus. What a lot of students do is go, oh, I get this. I'm going to put an electron there, and now there's a plus on this side and a minus on this side. Yes, that is not balanced. This side is now +1, this side is -1. That is wrong. All right? This one is correct. The plus and the minus. So overall, this side is now a charge of 0. Overall, this side is a charge of 0. All right. So I'm going to do the next one now. C is what I'm going to go to. B should be easy for you. All right. H2 to H plus. What was rule 1? Balance any elements which change oxidation state. Well, there's only one element there. H2 to H plus. I'm going to have to balance that. All right. The next rule is balance any oxygens, which there aren't any. Balance any hydrogens with H plus. I've already balanced my hydrogens, so that's fine. Fourth one, balance charges with E minus. All right, this side is 0, this side is +2. So I'm going to add 2 E minuses onto this side. So this side is now no charge, this side is 0. All right, all seems very straightforward. We've only really used a couple of the rules. I'm now going to go to F. E, right? You need to check back in a minute on that. It's tricky. All right, so I've now got F. SO4 2 minus turning into S. So I'm going to follow my rules now. All right, balance any elements that change oxidation state. Well, the sulfur is 0 here and the sulfur here is +6. So it's the sulfur. I've got one sulfur on this side and one sulfur on this side. So rule 1, they're balanced anyway. The sulfurs are balanced. Rule 2 says balance oxygens with H2O. So listen carefully. There are 4 oxygens here. So I'm going to put 4 H2Os on this side. That's what balanced oxygens with H2O means. I have fixed my oxygen problem. There are 4 oxygens here, there are 4 oxygens here. But please notice I've now just introduced 8 hydrogens. So this is when the next rule comes in. Balance hydrogens with H plus. Right, there are 8 hydrogens on this side. So I'm going to need to put 8 H plus on this side. All right. Now I'm going to balance charges with E minus. Okay. So I'm going to look at this total side. This total side is 8 plus and 2 minus. So this side currently is 6 plus. This side is 0. I've got to throw some electrons at this, some E minuses, to get these sides to be equal and balanced. All right. I'm going to put 6 E minus on this side. Now I've got 6 minus, 7 minus, 8 minus, and 8 plus. So this side is now 0. This is a balanced half equation in this new A-level style where I have used these rules. Balance any elements which change oxidation state. I did that first, they were already balanced. Balance oxygens with H2O, balance hydrogens with H+, balance charges with E-. Right, you have got a whole load of them on the other page to do. I'm just going to do a couple of random examples now, just to show you before you dive straight in. So, here's one here, the one that I did earlier, MnO4 minus turning into Mn2 plus. This is the one I showed you before. So the manganese is already balanced, so that's rule 1 is fine. I've now got 4 oxygens. I balance oxygens with H2O. That's my first job. There are 4 oxygens to balance, so I put 4 H2O. I've now got 8 hydrogens to put in, so I need to put 8 H pluses on this side. I balance hydrogens. Final step, so balance, hang on, let's look at the rules. Balance oxygens with water, balance hydrogens with H plus. Now then, this side in total is +2. This side currently is +7, H plus and a 1 minus. So I've got to make these sides equal by throwing E minuses at them. Because this side is more positive, it needs to be knocked down with negatives. I need to bring it down by 5. So 5 E minus goes on this side. This side is now 8 plus, the 6 minus, so that side is +2. This side is +2. That is a completed half equation. All right, your job is to now go through the rest of these and attempt them. I'm going to go through the answers. Please notice, if you're in my class now, if you just complete this, because I've done it, that is me learning chemistry. You have got to do this, and then you go through the answers on this sheet, and you check through afterwards. All right, I'm about to start doing these now. Please make sure you can do them individually. All right, so you can pause the video now. I'm going to do the rest of this task, starting now. Hopefully you did pause the video and are now watching this later. All right, PB4 plus, PB2 plus. The only thing that's different between this side and this side, the lead's balanced, the PB's balanced. There's no oxygen, there's no hydrogen, so it's just a matter of charges. If I put 2 electrons on this side, that will do it. 4 plus and 2 minus makes 2 plus on this side, 2 plus on this side. That's done. Br minus to Br2. So I'm going to write those in first. Br minus to Br2. First step is to balance the elements itself. I'm going to need 2 of them. Don't need to balance any hydrogens. Don't need to balance any oxygens. All I've got to do now is balance charges. Currently, this side is 2 minus, and I've got to put some electrons in. So I'm going to make this side 2 minus as well. That one is now balanced. I'm going to do this one in a minute, because I guarantee loads of you will get it wrong. I'm coming back to that one in a sec. All right then, G. Right, I start off writing the 2 species on here. Right, SO4 2 minus, that's a sulfate ion becoming H2F, that's hydrogen sulfide. Right then, sulfur's balanced, so I don't need to balance the sulfurs. Next rule is balance the oxygens with water. There's 4 oxygens, so I'm going to need 4 H2O. So balance the oxygens with water. Now I've got 8, 9, 10 hydrogens. See that? 8, 9, 10 hydrogens, so I'm going to need 10 H pluses on this side. All right, now I've got to balance the charges. This side has got a charge of 0. This side is currently 10 plus. This side is currently plus 8. So I need to add 8 electrons. I'm just going to squeeze them in the middle there. You can put them wherever you like. 18 minus. That one now balances. 10 plus, 10 minus. That makes 0. Next one. SO4 2 minus. Sulfate to SO2. That's sulfur dioxide. Alright, sulfur's balance. 4 oxygens, 2 oxygens, so I need to put 2 H2Os in. I'm balancing my oxygens with water. 4 hydrogens on here, so I'm going to need 4 H pluses. This side has got a 0 charge. This side is plus 4, this side is plus 2, so I'm going to need 2 electrons in there. Now the charge is balanced. Next one, N2 to NO3. Nitrogen. The nitrogens don't balance. Alright, this is nitrogen 0, this is nitrogen plus 6. The nitrogens don't balance, by the way, because there's 2 here and there's 1 here. Alright, so you're going to need to do that first. First move, don't forget the first move to balance the elements in question. Right, 6 oxygen on this side, so I'm going to need 6 H2Os. If I'm putting 6 H2Os in, I've now got 12 hydrogens that need to be balanced over here. 12 H plus. No charge on this side. I'm going to need 12 E minuses over there. Alright, so that one got into some quite big numbers quite quickly. Right, IO3, it's called the iodate ion, IO3 minus, turning into I2. Alright, firstly, 2 iodines here, 1 iodine here, so I've got to start off by doubling the IO3 minus. Now I've got oxygens. There are 6 oxygens on this side, so I'm going to need 6 H2Os. I've got 6 H2s, so that's 12 hydrogens, so I'm going to need 12 H pluses. Now I've got to do the charges. Careful here. 12 pluses and 2 minuses. So this overall is 10 plus on this side. So this is going to be 10 E minuses are needed. This side is now 0, this side is now 0. Alright, mercury, Hg 2 plus, turning into Hg2, little dimer of mercury, 2 plus. Alright. 2 mercuries on this side, 1 mercury on this side, need to do that. This side is now 4 plus, this side is 2 plus, so we're going to need 2 electrons on this side. Alright, VO2 plus, that's called the vanadate ion. This is VO2 plus. Different. Vanadium, 1 vanadium on each side, that's great, but the oxygens don't balance. 2 oxygens on this side, 1 oxygen on this side, so I need an H2O. Now I've got 2 hydrogens, so I need 2 H pluses. Now I've got to carefully look at the charges. This side is overall plus 2. This side is 1, 2, 3 plus, so I need an electron on this side. Next one, S2O32 minus, that's the thiosulfate ion. You might remember it from disappearing cross as it turns into sulfur, which is what makes the cross disappear. Alright, S2, so we're going to need 2 sulfurs. I've got 3 oxygens, so I'm going to need 3 H2Os. I've got 6 hydrogens, so I'm going to need 6 H pluses on this side. Now I've got to balance the charges, which is always the trickiest bit. 6 plus and 2 minus. This side is 4 plus. I'm going to need 4 E minus on this side. Put the pluses in there. Final one, NO3 minus into NO2 minus. We're going to do the oxidation state just for fun. Minus 2. That's nitrogen plus 5. That's nitrogen plus 3. By the way, you should know that from the last lesson. 2 oxygens, 3 oxygens, so I need to add H2O on this side. I've now got 2 H's, so I'm going to need 2 H pluses over here. Let me just do the charges now. This side is 2 plus minus 1, that's 1 plus. This side is 1 minus. How do you get from 1 plus to 1 minus? We need to add 2 electrons on this side. Alright, back to the chromium one that I reckon we're going to get wrong. Alright, Cr2O72 minus. Goes to CR, so that 3 plus. That completed. Alright, this is why you're going to get it wrong. A lot of you will have forgotten to do 2 chromiums if you're there. Alright, you might still be in the game. Let's see if you are. Now I'm going to balance my oxygens, so I'm going to need 7 H2Os on there to balance the 7 oxygens. You might still be doing alright. I've now got 14 H pluses. 14 H pluses, and this is where people go wrong with the charge. Alright, this side is 14 plus and 2 minus, so currently it is 12 plus over here, and this side is 2 3 pluses, this side is 6 plus. So you need 6 electrons on there. A lot of people just go 3 plus and then end up with 9 electrons here. If that's you, don't worry, it's just a common mistake. All right, what you've just been able to do there is writing half equations. You'll notice that some of these half equations, they lost electrons. There we go, the electrons are on this side. Some of them gained electrons. What's that? Oxidation is loss, reduction is gain. This is where we're going to with all of these. So you have learned the skill of writing half equations. So when nitrogen turns to NO3, it reacts with waters and it loses 12 electrons. So it's just a little introduction to the fact that a half equation tells the story of one element and how whether it gained or lost electrons. All right, that's all we're doing with this. What we're moving on to in the next video will be how we combine half equations. But that's not for now. Goodbye.